Wave basics. A wave is the transfer of energy from one place to another. There are two types of waves. One type is mechanical waves, and the other type is electromagnetic waves. Sound waves are mechanical waves because they require a medium, which is a physical substance, to pass through.
Mechanical waves. There are two types of mechanical waves, longitudinal waves and transverse waves. Sound waves are longitudinal waves because the motion of the particles is parallel to the direction the wave is traveling. The motion of the particles in transverse waves is perpendicular to the direction the wave is traveling. Although sound waves are not transverse, we will use transverse waves in some of our visual depiction of sound waves.
Longitudinal waves. Instead of going up and down, longitudinal waves travel by compressing and stretching their medium. The denser areas of the waves, where the medium is squeezed together, are called compressions. The areas of minimum density, where the medium is stretched out, are called rarefactions.
Parts of a wave. The highest part of the wave is called the crest. The lowest part of the wave is called the trough. The crest and trough are equal distance from the equilibrium position. The distance between the two crests is the wavelength. The amplitude of the wave is the distance from the equilibrium position to a crest or trough.
Period of a wave. The period of a wave, which is represented as t, is the amount of time the wave takes to go through one full motion. Period is measured in seconds. Period equals 1 over the frequency. The frequency of a wave, represented as f, is the number of times the wave goes through a full motion in 1 second. Frequency is measured in hertz. Frequency equals 1 over period. The velocity of a wave can be calculated by multiplying the frequency and the wavelength of the wave. The speed of sound in air is 343 meters per second. Velocity equals frequency times wavelength.
Superposition. The ability for two waves to overlap is called superposition. The resultant wave is defined as the sum of the wave amplitudes. As two or more waves pass through each other, a resultant interference pattern is produced.
Wave interference. When two waves overlap, their amplitudes will add together to create a new resultant amplitude. If both waves have amplitude in the same direction, constructive interference will create a larger wave. But when two waves have opposite amplitudes, one is positive and one is negative, and the waves cancel each other out, destructive interference is the result of the superposition of two or more waves with opposite amplitudes.
Reflection of waves. When a wave comes into contact with a fixed boundary, the reflected wave is inverted from the original amplitude. When a wave comes into contact with a free boundary, the reflected wave has the same amplitude of the original wave.
Standing waves. When a wave on a string is vibrated at the correct frequency, the wave will interfere with itself. This creates a standing wave, a resultant wave that appears to be stationary. Standing waves are formed when two waves having the same frequency, amplitude, and wavelength travel in opposite directions. Once a standing wave has been created, there are positions in the wave that appear to have zero amplitude or a constant large amplitude. A node is a point in a standing wave that maintains zero displacement. An antinode is a point in a standing wave halfway between two nodes at which the largest displacement occurs. Certain frequencies can produce standing wave patterns. The higher frequencies are known as harmonics. The fundamental frequency, or first harmonic, is the lowest frequency of vibration in a standing wave. Notice how the two ends of the string make up the two nodes, and there's only one place with the highest displacement, so there is one antinode. The equation for the first harmonic of strings is frequency equals the velocity over 2 times the length of the string. To find the other harmonic frequencies of strings, you must multiply the velocity over 2 times the length by the harmonic number of the frequency. Audible frequencies. The average human ear can hear audible frequencies from a range of 20 Hz to 20,000 Hz. Infrasonic sounds are below 20 Hz. This is the kind of sound that elephants can hear. Ultrasonic sounds are above 20,000 Hz. Bats can hear this kind of sound.
Hey, what's Sheldon supposed to be?
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Oh, sure, I see it now, the Doppler effect.
Intensity and the decibel scale. The rate at which energy flows through a unit area perpendicular to the direction of the wave motion is called the intensity of the wave. Because power is also the rate of energy transfer, intensity can also be described in terms of power. I equals P over 4 pi r squared. A decibel is a dimensionless unit that describes the ratio of two intensities of sound. The decibel level directly correlates to the level of intensity. Poor decibels, doesn't have a dimension.
It's also quite dangerous. The mandrake's cry is fatal to anyone who hears it.
Excellent. 10 points to Gryffindor. Now, as our mandrakes are still only seedlings, their cries won't kill you yet, but they could knock you out for several hours, which is why I've given each of you a pair of earmuffs for auditory protection. So can you please put them on right away? Quickly. Flaps tight down and watch me closely. You grasp your mandrake firmly. You pull it sharply out of the pot. Got it? And now dunk it down into the other pot and pour a little sprinkle of soil to keep it warm.
Resonance. Resonance is a phenomenon that occurs when the frequency of a force applied to a system matches the natural frequency of vibration of the stem, resulting in a large amplitude of vibration. Sometimes a frequency matches the natural frequency of an object, and crazy things happen, like when a certain pitch is sung so loudly that it breaks a glass.
Bingo!
Is it supposed to be that easy?
Beats and timbre. A beat is the periodic variation in the amplitude of a wave that is the superposition of two waves of slightly different frequencies. Musicians tune string instruments by vibrating two strings at the same time and adjusting the out-of-tune string until the beats cannot be heard anymore. Timbre is the musical quality of a tone resulting from the combination of harmonics present at different intensities. This is why instruments sound different from each other, like when you play the same note on the guitar and on the trombone, and they sound different.